Translation is the second stage of protein synthesis where a piece of mRNA is used to create a polypeptide chain. Firstly, let's go over the key terms. Remember that mRNA or messenger RNA is made up of codons. tRNA or transfer RNA has an anticodon on it, and the anticodon defines the amino acid carried by the tRNA. Translation takes place in the cytoplasm, and the first thing that happens is that the ribosome attaches to the mRNA at the start codon, which is AUG. The ribosome is made up of ribosomal RNA, rRNA, and ribosomal protein, and has two sites on it, the P site and the A site. A tRNA carrying the complementary anticodon to the start codon, which is always AUG, comes and attaches in the P site. The first amino acid associated with this is always methionine. A piece of tRNA having an anticodon complementary to the mRNA's second codon then floats in from the cytoplasm carrying the next specific amino acid. In this case, that's tyrosine, and this tRNA then attaches in the A site. A peptide bond is then formed between the first two amino acids. At this point, the tRNA that's in the P site, or you might want to think of that like the parking site, is no longer really required because its amino acid is attached to the amino acid on the second tRNA by the covalent peptide bond. The ribosome then moves along the mRNA by one codon. This places the second tRNA in the P site, and the first tRNA is then free to break away. While it does so, a new tRNA with an anticodon matching the mRNA's codon and carrying a specific amino acid can then come and join in the A site that's been freed up. Consider this an attachment site. A peptide bond then joins this new amino acid to the existing chain. And so this process continues. The ribosome always moves down by one codon, and once it's done so, it means that the previous tRNA that was in the P site is able to break away, free from its amino acid, and allow a new tRNA with a new amino acid to come and join in the A site that's freed up. The new amino acid can then join the existing polypeptide chain with a peptide bond, and the tRNA that was freed up goes back to the cytoplasm and collects another specific amino acid ready to be used again. Note that the amino acids used are specific and defined by the codons on the mRNA and complementary anticodons on the tRNA. The process is somewhat repetitive and continues until the ribosome encounters a stop codon on the mRNA. The stop codon does not code for an amino acid, but merely indicates where the process of translation should terminate. Once the process has been terminated, the polypeptide chain, tRNA, ribosome, and mRNA detach, and the polypeptide chain becomes free-floating in the cytoplasm. Thus, in translation, overall, we have used the mRNA to form a polypeptide chain.